Did you get from there though? Okay. Something really what you need. You really need to calculate it for this. These are good. You need what's right. No, I'm just usually these almost the vertical should be almost to a very good. That's what's mine. What is that? The x value vertex. Yeah. So then look at the vertex. This is negative b over 2a. And then this is what? Y. The y value. Yeah. Okay. Or put it in terms of the function f of negative b over 2a. F is the inverse, right? No, not the inverse, just a short way to say this is the y value when the x value is this. Okay? So that's the vertex. Now that's that part. What else is this as an equation? X-intercept. Not the x-intercept, but the x value. Almost. What's the other piece? Yeah, 2 words. Actually, 3 words. What's the, well, what is all this dealing with? It's the maximum minimum value of the, first off, what are we dealing with? What kind of function are we dealing with? Quadratic. So in the quadratic, we need to have the axis of the, yes, there is the axis of symmetry. And remember that axis of symmetry must be in equation form. It must be in x. So the axis of symmetry, knowing that axis of symmetry is not only gives us that, but it also gives us the x value of our vertex. Well, knowing the x value of the vertex in the equation, we get y value of the vertex. So there's 2 things that we can get from this. So we would get the vertex, the axis of symmetry, okay, and no, we get that x and x. No, we go out. But, well, it means if you want to. What does it mean to have? We can, we certainly can. What does it mean to have an x-intercept? What does it mean to have a y-intercept? Where are the graphs? Or else? Crossover to what? Each other. Not each other, so only one graph. So not an intersection. This is an intercept. All intercept. When we're looking at the intersection of 2 graphs, that's not the intercept. The intercept, we have an x-intercept and a y-intercept. Intersect what? It is an intersection, but not of a different graph. What's the other piece that's on the graph with the convex? Think about it. What's the equation of this graph? Minus 4x squared. Oops. You get 4x squared plus 32x is minus 28. The equal sign there? No. This is f of x is equal to that. F of x is equal. So, in other words, y is equal to negative 4x squared plus 32x minus 48. Well, to get all of this, keep in mind we have to have our function in ax squared plus bx plus c form. Is that in this form? Yes. So we can easily pick out a, b, c. Well, for this we need negative b and a positive A, or the A value. Well, now, when we graph this, you keep talking about something. When we graph this thing, what are some of the things that we look for to get the graph? When we graph this. Okay, we look for a minimum and a maximum. Okay, a minimum and a maximum. What are the minimum and maximum found? We also know that as well. The minimum or the maximum of the parabola is what? What is it? Where is it located? Either top, which would be what? The minimum and the maximum is the vertex. So if I'm looking for the minimum or the maximum, I find the vertex. Well, if I find the vertex, I really need, in this one, I really need to find the axis of symmetry. So knowing the axis of symmetry gives me 1, 2, 3, okay? The axis, that equation is the axis of symmetry. That x equals negative to the is the equation of the axis of symmetry. Remember, when I ask for the equation, it must be in equation form. Okay? If you just give that part, negative equal to it, it's not the equation. It has to be in equation form. Okay? And it's always going to be x equals, because x equals is a vertical. Right? Well, back to this thing. Well, if we have a minimum or a maximum, what else do we know about okay, we know that it either opens up or it opens down. What's something else? Say it one time. It's going to be opening up. We have 2 options. Actually, 3. What are those 3 options? Okay. The view. So it determines whether the parabola opens up or down. So it's positive, opens up, it's negative. Okay. So yes, A determines opening up and down. Well, where's A here? Negative. So is this thing going to open up or open down? Okay, so we're looking at this. So right away we know it's going to be opening down. Well, what else? What else? When I think about this thing opening down, okay, what else? What other question, I should say, should pop into your head? It deals with that vertex. Where it crosses the x-axis. Okay? Crosses the x-axis. What's going to determine? Or what crosses the x-axis? Whether or out crosses. Then I have 3 options. What are my 3 options? When A is positive, when A is positive, parabola opens up, or when the vertex is below the x-axis. The second option is when parabola opens down and the vertex is above the x-axis. Wait a minute, don't confuse me. A doesn't something whether it opens, or excuse me, where the axis, excuse me, the vertex is either above or below the axis. A doesn't dictate that. A dictates whether it opens up or it opens down, and how wide or how skinny it is. Yeah. But when we dealt with that vertex and where it is, what 3 options did we have? So we know it's opening down. What options do I have for this thing opening down? It's either on the x-axis. It's on the x-axis, that's above or below. So this thing is going to be my x-axis. Is either going to see my vertex is either going to be above my x-axis, it's going to be on my x-axis, or it's going to be below my x-axis. Well, what good does that do? What does that tell me? Well, think about it. Look at this visually. If it's above, lean down, what do you know? Maybe it's a positive. The vertex is. What do I know about? The x-intercept. Oh, it's negative. Not necessarily. This is when we know this guy. What does it mean to have an x-intercept? We also call those roots, solutions, or zeros. What does that mean to have an x-intercept? What does that find?
So what does it have?
What is it? What is an x-intercept?
X-intercept is
So if I put it here, how many x-intercepts do I have? 2. What does that mean? What does that mean? Visually, what does that mean? How do you know 2? Why not 3? Why not 4? Why not 20?
What's that for? The cost is going to come down second day.
So what's the next intercept? What did you just say?
2.
2 what? What did you just say?
2.3.
What are they? Where are they?
Side.
What's that?
The x-axis.
Where? Way down there? Way out here? Where? How do I know that R2?
How do you know there's two?
Right here. How do I know? This is where my x-axis is. What to? Where to? How do you know that R2?
Because it crosses it passes it touches and goes past the x-axis.
Goes past it, so it jumps over it?
No, intercept.
So where are my x-intercepts?
Right, that touches the x-axis.
So my x-intercept is where I touch the x-axis. Where the graph touches my x-axis. Okay. Well, what's a y-intercept then?
Where other touches the y.
And there you go. Touches. Okay. Well, now, if I just look, that means axes. If you know, every single point on that x-axis has something in common. What is it? Every single point on that x-axis has something in common. Every single one of them? Even these values down here? They're all numbers, okay? Well, what are numbers? What does a point have? Well, not necessarily, it's not just natural numbers, okay? What does a point have? Every single point is what? It's 2 things. What are those 2 things? It's 2 things. Start with C.
Coefficients.
Not coefficients. What do you have to have to know where a point is?
Coordinates.
Coordinates. Which coordinates? X coordinate and the Y coordinate. Okay. Well, this one point here, where the x-axis and the y-axis meet, what do you know the coordinates of that point? 0, 0. So this point is 0, 0.
Is that the same?
What about that point? What do you know about that point?
that is
X is always
no,
zero.
yeah, no, X is going to be something and Y is going to be zero.
Exactly. I don't know what it is, but it's going to be x and 0. What about this point out here?
Yes, those are x over something.
X is going to be some number, and then the y is going to be 0. What about over here?
X will be
Negative
negative.
something.
Negative something, but the y is going to be 0. So every single x-intercept has what I covered. Which coordinate? Which one? What you just tell me? What's this guy right here?
Negative.
So negative number and
Zero.
0. See anything in the bottom?
You'll have 0.
Right.
On the x-axis.
On the y axis.
Oh, sorry. No.
My question.
Y coordinate. Okay? Every single x-intercept has some x value. Y value is 0.
So it's the same thing for like, so
Well, define the same thing, because I don't want to say it's x is 0, because then it would be the x.
you'll have a y, but it'll have zero. The x will be 0, but it's
Y-intercept means that all the x's are 0. You have some y, because it's the same thing. This is going to be some positive number. Whoops. Sorry. Some positive number for my y, for my x is 0. This is 0, 0. Down here, it's going to be some negative number.
all right, so
Putting it in thinking not going anywhere on my x, but I'm going down on my y. So now all of my x's, all my y-axis, all my x's are 0. All my x-axis, all my y's are 0. Well, what good does that help us? Well, I'm trying to find the x-intercept of this. X-intercept means that I plug an x and a 0 in for my y. Well, there's my y. Close.
oh, that's what we always have the 0 to 0.
Okay?
And what did we do when we had the 0?
What did we do?
What was the first thing we did? When we set this thing equal to 0, what did we do? What was the whole process? We were doing what? You now take what do you do? That's right. Oh, we get the solution.
What's another word for a solution? How do you get to a solution? You do what? What's the process called that you are using to get to a solution? It also starts with this. Sure. Sometimes we add more, whatever. What's that whole process called? That's interesting. Sometimes we ask things that be very short word. What's the second thing? Oh. So we do this a lot for x. Solve. We solve that equation for x. Okay? To find the x-intercept, we solve that equation for x. Well, what processes do we have to solve for x? Let's say quadratic. How do I solve a quadratic?
How do you solve one another?
Use the formula.
Which the quadratic formula. What else? Calculator and find the
Substitution, calculation, and
the zeros. Okay? Or we could, well, I can't do substitution or elimination because substitution or elimination means that I'm solving a, when did we do substitution and elimination? And the matrix, we solved a what?
You get to
Yes, we had two equations, we solved that system. Here, we're going to use a quadratic formula, or I'm going to graph, or matrix, not matrix. What else did we do? We could use polynomial, okay? Or I can factor. Okay, so remember, when we're solving a quadratic, we're either going to use the formula, we're going to use a calculator to find the zeros, we're going to factor, that's it. For some two, we could use that.
oh, the minus b one.
I'm sorry.
Is the formula minus b plus or minus?
Yes, the x equals negative b plus or minus b squared minus 4ac all over 2x. We're going to use that, which is why we started with all that quadratics. We solved quadratics. Now we're analyzing quadratics. We're taking this thing, we're analyzing, and then we're going to go backwards. At the end of this, we're going to take all the given information and break the equation. So now we're taking the equation and we're analyzing, getting all the information from it so that we can graph it.
Then we're gonna take the graph and go backwards so that we can come up with this guy at the end. So we gotta take away so we have a two-way street. So now, if I'm the x-intercept, so I'm the solutions of the set. Should we graph or up to you? You've got 4 ways. Your choice. Six or two? How do you, which way do you use box? You're right. Okay, good. This line. Intersect, but that's why I did this. I'm not looking for the intersection. I'm looking for the intercept, the difference on what calculator. Which is why I'm looking for the zero. Yeah, you use the end. Back. Now, what's it tell you to do? So you have to set your cursor to the left. Should tell you what. So you see it -3. Is it really closer to you? Now, there's your cursor. You have 2 places where it's across the exact. You have to put that cursor to the left. Okay. That's right. Now, right now. You're looking at right there. So you already set the logo to the left. So now you're to the right. As long as it's to the left and to the right, you're good. Now, when it says yes, make sure that you put the intersection. Your zero is between the bars. Is your zero between the bars? Your zero, not the zero. Oh, right. But the zero, the x-intercept. Yes. Okay, so now you're right. And what's your x-value? 2. Right? So that's 2. Now, how many times is it across the x-axis? Just count how many times. You see that thing cross 3 times?
No, sorry. I'm sorry, I didn't hear you.
How many times did that blue graph cross that axis? Cross that x-axis? 2 times. So how many times do you do that? 2 times. So you have the same time.
So I need to go back on that side.
Well, first you need to go back into your intersection. To your 0. So second trace. 0. Now, you want to be to the left of that guy. So use your arrow.
Does it come back?
Here. Here we go. No, to the left. So right now. Now, to the right. So now
And
No, is your zero between the bars? Just simply do it.
0.
And then 0. Okay, so for this,
Our x-intercept was, we have x is equal to 2 and x equals 6. We can write this two ways. I can write it as a 0.20 and 60, or I can write it as x equals 2 and 6. Either way, both of those are acceptable on it. Okay? Now, if they just ask for the x-intercept, if they ask for the coordinates, the x-intercept, then we have to put it into the coordinates. They occasionally do that, where it says, what are the coordinates of the x-intercept? Not very often, most of the time you're gonna see what is the x-intercept, write down the x-intercept, find the x-intercept. That's different. In that case, then it doesn't matter which one of these you write. Okay? Well, now, that's the x-intercept. Now we gotta do the y-intercept. How do I find the y-intercept? What is that? 0. 0 for what?
With the graph on the right.
Okay, so 0 for the what?
X has to be 0.
X has to be 0. So I put 0 in for my x and I find my y. Okay, here we put a 0 in for y. And so for x, here we're going to put 0 in for x. Oops. And so y. Go back. I start with y is equal to -4x squared plus 32x minus 48. Plus 0 for x. Keep my y. -4. 0 squared plus 32. 0. That's 48. Minus 48 is what? That's 0 squared times -4. 0. 32 times 0. 0. Just leaves. And again, doesn't matter whether I write it like this or if I write it like this. Okay. Both of those are acceptable. Now we've got our x-intercept, our y-intercept. I can still find my axis of symmetry, and I can still find my vertex. All of those are the things that I need. Okay, so in this, let's get this guy out of here. Different color. Okay, so my axis of symmetry, x equals -b over 2a. Back in my original equation, the one where it's all my stuff is on this side, and my y is on the left. It's my b, 32. So this is going to be that negative is part of the formula. B, right there, 32. Over 2 times what's a? -4. Now, just bang this thing out. Nothing to do at the top. -42 over -8. Okay, so x is equal to 4. That's my axis of symmetry. X equals 4.
So that's a vertex? No, that's a vertex axis.
So only part of my vertex, what part? Okay, so I can go over here, my vertex, and I know my x value is 4. I gotta find that.
So you plug into
So I'll go back to my y equals -4x squared plus 32x minus 48. -4 times 4 squared plus 32 times 4 minus 48. So this is a lot of work, right?
4 squared, that's 16, 16 times -4, so that's -64. 32 times 4 is, well,
I'm trying to use.
28 minus 48. See how many times you can make a mistake, right? Right? Well, 64 and 48, those are both negatives, so I can put those together. And we get -112 plus 128, or -112 plus 128, 128 minus 112 gives me there's got to be an easier way to do this. Oh, what did we say the vertex was?
What was this thing? I mean,
The vertex. Can I do that on my calculator?
yeah.
We can do that the same way that we did with our graph. We'll go back to that.
What I made it first.
Well, which one does this have? Does this have a minimum or maximum?
How do I know? How do I know this thing has a maximum? I didn't know it's supposed to. How is it?
It's negative. Like A is negative. So I know that it's going to have a maximum. Look, you're trying to find a maximum. So you use the maximum. Right. And it works very much like the zeros, because it's kind of asking for it's a macro, and so you find the it's a flow.
So after you put edge over here, should I,
So you go to the right, also cursor to the right. It's to the right. It's to the right of your maximum. So nothing there. Now, is that maximum between those two rows? Those two bars.
okay, so it's 4.
What's
So, maximum, x is 4 and y is 6.
What we got? So what we did here is not very fun. We'll always have a calculator available to you. It's not the yours that you choose. I use it actually. So now, set that cursor to the left. Left of your maximum. So it's definitely to the left, not so to the right. Is your maximum to change to it? Yeah. Okay. So now, our work has now been verified by this. Now, the only time that I'm going to have to go through this when you see it show them. If it says write down the axis of symmetry, where is this axis of symmetry coming from? We said that axis of symmetry is what? Where? Where else is that axis of symmetry?
How where is it after the axis? When you solve it.
Right. Here.
Why is it X, Y, Z?
It's my axis of symmetry is where?
X.
Of the which?
Vertex.
And remember, we said,
Yeah.
okay, my axis of symmetry is the same as the x, y, and my vertex. What does that mean for me as far as my test? I don't see this. In other words, if I see right down, the axis is the equation, the axis of symmetry. I use my calculator to find the vertex because my axis of symmetry is the x value of my vertex. So I personally do not have to calculate it. I let my calculator find my vertex. And I know that my axis of symmetry is the x value of my vertex. Because the axis of symmetry is that guy right there. We talked about the other day. It's that mirror that goes through the vertex. So unless you see the words show that, you just calculate. Because most of the time, it's not going to be a showdown, and you write down. Write down according to the vertex. That is telling you that I need to say, use your calculator to find the vertex. Done. Now, if you want to, you most certainly can do it like here. But it's going to cost you a little bit of time as far as your exam. Does it mean anything? No. You can certainly get it, obviously, because we got it by hand. And we backed it up by our company. So it's whichever you're comfortable with. I would suggest that you get very comfortable with the calculator, because it's going to earn you extra time. Remember, we want to get down to that 1 mark per minute. And these breakdowns are only 1 mark. So if it says write down the axis of symmetry, write down the vertex, it'll be 2 marks, 2 minutes. It took us longer than 2 minutes to do that. That means we are losing time. Does that make sense? Okay. So it took us a little bit of time this time using the calculator because it's kind of clunky, it's kind of new. But if we can perfect this, and if we can get that motion down, and know how to get it very quickly, we can get both of these at the same time. And these 2 minutes now become 20 seconds in our game over and half. Okay. So we want to start working towards that. Right? So we look at that paper, what are the things that we need? So we got the vertex, we got the x-intercept, we got the y-intercept. Okay? We got the axis of symmetry. Well, does it have a minimum or a maximum? Maximum. Okay? Where does the maximum or minimum occur? Okay, what kind of question is that? That question is just asking, where is it? Or where is the maximum or minimum? Minimum or maximum is going to occur at the vertex, which you just found the vertex. So essentially, that question is asking you the same thing twice. Okay. So it's just a play on whether you know your vocabulary. The only one that we haven't touched on is the range. Okay, and the range are the passable y values.
Well, the good thing about this is the range. We've essentially already done all the work to find all the possible values. Because we look back at two questions. Does this thing open up or down? That's the first question. Second question is, where is the vertex? Or the maximum or minimum? Right? So, does this thing open up or down? Down. Yeah. Okay. So we're looking at, we're looking at something like this. Right? Now, where is the maximum or minimum? Where's our vertex? Which is 416. Now, if my range is my possible y values, is this thing a maximum or a minimum? Maximum. Okay. That means, can my y values be any bigger than 16? No, because it's a maximum. But they can't be bigger than 16, so what?
So 16 is the maximum, 4 is the minimum.
4 is the next value.
16 is the maximum.
Okay, so what's my minimum?
So, negative 16.
Negative 16. Why negative 16? Does my parabola stop?
It's where the x is.
What makes that difference? Because if I'm not dealing with a certain situation, you can continue with that. Is there a bottom?
Base.
Not a base, bottom.
No, just keeps going.
Keeps going. So the only thing that I can say is that I know that I have a maximum value of 16. Mathematically, how do I say that? If I had a maximum value of 16, and it can be anything lower than that, mathematically, how do I say that?
16 is greater than
16 is greater than
0.
not 0.
All we want
Alright. And not just greater than.
greater than 14.
16 is greater than or equal to y, or y is less than or equal to 16. Well, my y values can be any value, as long as they're not bigger than 16. Okay. So we have answered every single part of that question.
How would come in?
The domain.
Is it all the numbers?
The domain, okay, the domain are possible x values.
So you heard what all the numbers on the test, right?
Why does it all go?
Server should all the time. When you get quadratics, you just want to like multiply. Because that's what he said.
Why is it all there? Look at it, it's the possible x values. In other words, it's all the values that I can put into this function. Well, here's my function. Can you give me one x value that I cannot put in here? Can I put in positive numbers? Can I square positive numbers, multiply by -4, multiply them by -2, and then combine all those? Can I do that with negative numbers? Can I square a negative number?
Yeah.
Yeah. Can I multiply a negative number times a positive number? Can I add those results? So I can do that with positive, I can do that with negative. Well, the only other, if it's not positive, it's not negative, it's what? 0. Can I put 0? Can I square 0? Sure, because we did it right here.
Then that was 0.
So I still can. So if I can put every positive number in, I can put every negative number in, and I can put 0 in, that's fine. Because there is not any number that I cannot put into there. That's why I can say all.
You remember how to write that? I divide x even r. It's a, it looks like
Yes. X,
funny looking e and then r with a minus side. And then funny looking r. Okay, double bar r.
X is the element of the real numbers. Meaning there is no number that I cannot put in. Okay. All right, so those are all the ways that we can attack this problem. Okay. Now, for that first problem, all of those things are written out. Okay. They're not always going to be written out. They're not always going to say, okay, part A, find the vertex, part B, find the x-intercept, part C, find the y-intercept, and so on and so on. What it might be is, here's your function. Write down the axis of symmetry. Write down the vertex. Is the point 2, 3 a solution to this? How do I determine if 2, 3 is a solution? Are you confused? If, say, okay, if my question now is, if I have the same function, and this is not a question one, right? I left it off. But if I said, okay, is the point 2, 3 on, whoops, not on f of x, on the graph of f of x. How do I determine this? Plug what into the equation? 2 and 3. 2 goes into where? X. 3 goes into the y. Okay, so put it in. So 3 goes into the y. -4 times 2 squared plus 32 times 2 minus 48. Well, 2 squared is what? 4. 4 times -4. -16 plus 64 minus 48. Well, what's 16 and 48? -16 and -48 make what? Or just put -16 plus 64. So -64 plus 64 equals, what's -64 plus 64? 0. 0. So now the question is, does 3 equal 0? No, that's not true. Well, if it's not true, is the point 2, 3 on my graph? No. Not on the graph. It would have to be a true statement. This statement is point. Okay, so to determine if the point is on the function, we plug it in and then look for a true statement. This was false, so it's not on the graph. If it came out to be true, that would be on. All right, now, like I said, now we've got the full one way. Now we gotta go reverse. Okay, now we're gonna take all this information and we're gonna come up with this guy. Okay? Yes, stretch. Okay, it's a lot of work. Stretch. Get your brain going.
It's like ACT so long.
Was? Taking it?
Yeah. See, you know, that's PSAT, which you don't know how to do.
Some math. Some math.
Backwards, like it.
Multiple choice math.
Yeah. If you have a multiple choice and you don't know how to do it,
Substitution.
substitute.
Substitute values and if they work, that's your answer.
Oh,
If they don't work, if they don't work, it's not your answer. SAT is not always about what you can or what you cannot do. It's can you take a test. Okay, so the next time you sit for that, you'll realize SAT. Okay, if you don't know how to do mathematics, try to do a process of elimination. Plug those answers in and work your way backwards. If they work, that's your answer. If they don't work, you got a false statement. That's not the answer.
And then the other part, one of the questions is, okay, there's some tricks, and we try to go through some of those later. There's some tricks, and the SAT says this is what you eat, this is what you look. It says this is what you eat. Okay. So there are little tricks and tips that will pull out and start doing more and more of those. It's really, the SAT really is more about whether you can take a test and comprehend you versus what's on the test. It's not. It's supposed to be an aptitude test. It is an aptitude test, but it's only an aptitude test. The test has essentially some knowledge. If that's geometry, algebra 1, or algebra 2, that's it, top out. No pre-calculus, no calculus, none of that. And you get to the subject matter, and then that's a little bit. But the regular general test, no. So keep that in mind. If it looks really complicated, chances are it's really not. It's a little bit more simple than you think. Plus, if you get to a point, it's not like the IB. They're kind of all equal points. You get to it, and you don't know how to do it, you're just sitting there for 5 minutes. Just get it. Put an action. You go look, you venture, you play. It's going to count against you a lot less than you take a game. It's always that. Okay. Now, if you could narrow it down to 2 choices, then it's good to take a guess. But if you can't, you got all 5 choices, you got to find out who probably straight through them. Now, if you start skipping and you haven't had any problems in the section, you might be in trouble. Okay. But you should be able to do so. And it's progressive. Each section is progressive. Harder questions are at the end, easier questions are at the beginning. You start to get slower and you come out and you can't do it anymore. Skip it, go to the next one. You might go to that. Don't spend a lot of time. Go to the next one, go to the next one. Okay, because they want to get the rest of the card. Hardest problems are at the end of the section. Not necessarily the last section because in the section 2 up, but it's from question 1 to question 20. You get harder. All right, so take a breath before we go to the next one. I'll actually do the next one. Absolutely.